So here is a couple examples of how to find what we call b in an exponential equation, where you have exponential growth or exponential decay. So for this first one, we'll see if n is decaying exponentially here. So n is going from 120 to 96 as w goes from 0 to 1. We're going to try to continue this exponential pattern and find the decay factor that we need, and then use that to fill in the rest of the table. So when we say that n is decaying exponentially, what that means is that there is a way to write a formula for n as an exponential function of w, which would look like this. We take the starting value times the b to the power w. And if it's decaying exponentially, it means this b should be less than 1. So let's see what we can do to see if we can find a and b so that we can get a formula for n in terms of w. So, because we need to know what a and b are if we're going to actually plug in w equals 2 or w equals 3 into this. And the b is called the decay factor. So I'm going to do this kind of the long way, and then I'll also show you the sort of short way too. So I guess what I would call the long way is just plug in 0 and 1 to try to get a couple of equations with a and b in it. So if you plug in w equals 0 on the right side here, that will give you a times b to the power 0, and the result there would be 120. So I'm just plugging in that 0 and 120 in here. So, and of course b to the power 0 is 1, anything to the power 0 is 1, so that tells you that a is 120, which you knew because this was just the first thing, and when you plug in w equals 0, and a is always the starting value, so that's that. So now we can say that we know that n is equal to 120 times b to the w, but we still don't know what b is. So next, let's plug in 196 here for b and w. So b to the power 1 should make the result become 96. This will help you find what b is. So to get this b, you can just divide both sides by 120. And that gives you 96 over 120, which comes out to 0.8 equals b. Now here's a quicker way you can get b. By the way, this gives you the formula for it now. Now that you plug in your value of b and your value of a into this, the actual formula is n equals 120 times 0.8 to the power w. And you can check that works if you plug in 0 and 1 into w. Make sure you get the right n. This you can use to fill in the rest of the table now. But before we do that, let me show you the quicker way of doing this problem. So this was maybe a slightly more confusing way. The other way I would do it is just say that the definition of a decay factor is how much the output gets multiplied by every time the input increases by 1. So in this case, how much n gets multiplied when w increases by 1. So when you go from w equals 0 to 1 here, you want to know what is the b. So you could just think of this as we want to multiply the input 120 by that decay factor b to get the next one, which is 96. So then you could just solve that equation by dividing both sides by 120, and you still get the same thing. 96 over 120 is b equals 0.8. And by the way, you know that this is a decay factor not only because 96 is less than 120, which means it's going down, but also because this number is less than 1, which means every time w increases by 1, you're going to multiply by another 0.8 here. So multiply that by 0.8. That's going to make it smaller. So doing this the shorter way over here, we can just keep multiplying this by 0.8. So if you take your calculator here, we can do 96 times 0.8. That will be 76.8 here. You could also do that times 0.8 again to get the next one. And you get 61.44, and then that times 0.8 again to get the last one we need for the table. Whoops. And that will be 49.152. So that works using this kind of short way I did here, but you could also do it with this long way, which is going to be important sometimes as well. And you could check that this works. So like if I want to make sure I get the same 49.152, if we do n equals 120 times 0.8 to the power 4 here, because we're at w equals 4, and see what we get. 120 times 0.8 to the power 4 is the same thing. So that also works. Okay, so that's a couple ways to do it. Either thinking of the decay factor as just how much you multiply each time to go to the next one, and then just to continue filling in the table doing that. Or you could also do this other process to find a formula for the function by actually finding the values of a and of b here, so that you can plug them into a formula for it. Okay, now let's look at a similar sort of situation where we're going to be doing the same thing. We're going to be finding a growth factor in this case, and finding a formula for f of t. So in the 2000s, Riverside County was the fastest growing county in California. I don't think that is true anymore since the 2008 financial crisis, but it was at the time that our textbook was written. So in 2000, the population was 1,545,000, yada, yada, yada. And in 2004, 4 years later, it had grown to 1,871,000 and some change. So let's find an exponential formula for f of t. Which gives you the output is the population t years after 2000. So if it's f of t, it gives you the population and it's an exponential function, I meant to say, it would be a times b to the power t. And we need to find the a and b. To actually get a complete formula. And then you could use it to estimate the population in the future too, if that were to continue. We could find the population in 2008, assuming that this exponential growth continued. And sometimes exponential growth continues for a while, and sometimes it stops. And we'll talk about that in class a little bit. So let's see what we know. We know that in 2000 here, the population was 1,545,387. So 2000, that means t equals 0 years after 2000. So that one is talking about f of 0. And you're going to get a times b to the power 0 there. And that result should be equal to 1,545,387. And because b to the power is just 1, this tells you your value of a is just that number. So, because it's a times 1. So that's a. So that means we know we can plug that number in here into the a in the formula, so that will help us find b now. B to the power t. By the way, you might be able to just do that because you know that the a represents the starting value, and it tells you where the population started in 2000. So if you can skip this first couple of steps to find a, that's okay. You don't need to write that down. The trickier part is finding b, which is going to be the growth factor in this case. It's a growth factor because the population is growing. So what we're going to do is plug in 2004 here to see what the population is there. So 2004, that means 4 years after 2000. The population is going to be 1,545,000, yada, 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 times b, which is still unknown, to the power 1,871,950. No, that is not what I meant to say. We're doing b to the power 4 because we're plugging in t equals 4 there. But then the result, the actual population, is at 1,871,950. So that's what we're plugging in there. So that gives you an equation you can solve to find b. I can divide both sides by this number, and I did that division with my calculator and rounded it off to 1.211. Then if you want to cancel out the fourth power, you can take a fourth root of both sides of that, which by the way, is just the same as raising both sides to the 1/4 power, which is handy when you want to plug it into your calculator. I'm just going to take that answer to the power 1/4, and you get 1.049. Approximately. So that gives you your value of b, and we already know a, so now we can plug that in to your function and say that the formula now, that's just in terms of t, not in terms of a and b anymore because we found those, is going to be that starting population times 1.049 to the power t. And so that's what the question is asking for, so we can stop there. So we could also, if you wanted to, find what the population would be in 2007. This question doesn't say to, but this is why this function would be useful. You could find f of 7 by plugging that into your calculator if you wanted to. And it's going to be 1,545,387 times 1.049 to the power 7 if we're plugging in t equals 7. And that tells you the population would be over 2 million at that point. And at that point, I think, is when people stopped moving to Riverside County, and the financial crisis happened, and people started moving out of there, and it's maybe a little bit smaller than it was now. I'm not sure, actually. I should look it up. Anyways, that's that. It's a tricky kind of problem, but we've got the tools to do it as long as you know how to write a formula for the exponential function, and you know what the value of a really means and what the value of b really means here.